Ajá. Oye, cínico. El boss. Sí, Maxtos. De norte a sur se quema mucho marihuana. De este a oeste se habla de muerte en la semana. De norte a sur la calle es fuerte. Del mismo tono que de este a oeste. De este lado no se canta como golondrina. Acá se mueve y se conecta en todas las esquinas. Los callejones parecen campos de pelea. Aquí se activa todo el vato que se crea fiera. Sálvate de esta, no creo que tú me la
Watching Pagitics have Formula One car in digital age. We are a student of Facultad Ingeniería de la UNCU and let us present our
Yeah, turn me up.
Understanding the aerodynamics of F1 car. What is aerodynamics? It is the science that studies the motion of bodies through the air, and it's a vital factor in the performance of a Formula One car. Computational fluid dynamics. In car industry, the computational fluid dynamics is commonly described as a virtual wind tunnel. The LPD has quickly become an essential design tool for the leading teams. Using enormous computing power and sophisticated software allows engineers to simulate and analyze the aerodynamic properties of a piece before manufacture. The initial point for a LPD simulation in a car's model using computer-aided design CAD subdivided in many triangles to create a surface grid. At the same time, a similar process is carried out in the air around the car to create a volume mesh. When this process is completed, the resulting model is loaded into a supercomputer where a sophisticated software called LPD solver computes equations for calculating the airflow around the car with a surprising level of accuracy. Also, the LPD is used in the design of components and can also be applied to solve fluid flow problems. Likewise, the LPD is used in the design of turbines, internal combustion engines, and exhaust flow, simulating the flow of gas in a full tank while the car moves into a race track, and analyze heat transfer and measurement brake temperature in the endless race to lose times in tenths, hundredths, and even thousands of a second in race cars. Formula One teams focus more and more on high technology. Computing is becoming powerful, therefore the LPD will become increasingly important in car industry design. Main parts of a Formula One car. A car of Formula is divided into three main parts. First, the front wing. Second, the body car. And third, the rear wings. Each of these can be optimized to provide the necessary downforce car with a minimum of drag in a given circuit.
A Formula car is a very complex system. Each aerodynamic component must be tested individually, evaluate their effect on the bike. However, you have to understand the same behavior depends of all the components of the car's aerodynamics package. Important aerodynamic elements: wheels. Exposed wheels, Formula car fixtures, are the antithesis of what's considered an optimal aerodynamics because they generate significant drag and lift. In addition to air, turbulence generates major detrimental to the proper functioning of the car aerodynamically. Wings. The front and rear wings gives to the car the total of 60–70% of downforce. Its functions is not the same as the wings of an airplane. That is, in car the wings works to propel or push or proceed into the floor. The front wings have cold employed, which prevent to some extent the turbulence effect generated on the front tires, minimizing the drag resulting. The air effect is mainly on the front of the car. The hind wings exert their effect into the rear part.
Vanes bodywork. The shape of the vanes bodywork depends on the effect you want to produce on the rear tires, and generally their function is to minimize the drag produced by them. They can also have extra elements that generate more downforce. Suspension. The front suspension of this kind of car has a special aerodynamics design which decreases by up to 10 times the drag produced by traditional suspensions. This has been all, my friends. Thank you for seeing us, and don't forget to comment or give us a like. See you next.